Hello and welcome back. Let's continue looking at some higher order derivatives. So here you see our first g. So this number up here does not mean g to the fourth power. It means the fourth derivative of g. It's written in parentheses so that we know that we're not taking g times itself 4 times, but it means something slightly different. So here, so g of x is just going to be 1 over x, which we can write as x to the negative 1. And that's going to make this question a lot easier to find. So if g of x is going to be x to the negative 1, we can find the first derivative of g pretty easily. We can bring down our power and raise it to the 1 fewer power. And by continuing to do this, we can find this derivative rather easily. But we can see what happens over time here. So if we take the second derivative, g, we have our factor of negative 1 out front, but we have to pull down an extra factor of negative 2, and we'll take x and we'll raise it to the negative third power. If we want to take the third derivative of g, here's where we can start using our numbers. Can write triple prime, but at that point it's starting to having to count little lines, which is maybe a bit annoying. So again, we have the factor of negative 1 out front. We've got the factor of negative 2. And now if I pull that down, I'll get a factor of negative 3. We'll take x to the negative fourth power. And then finally, our fourth derivative of g, which is what we were asked to find originally, is going to be negative 1 times negative 2 times negative 3 times negative 4 times x to the negative fifth power. So again, one fewer power up top, so 1 less than negative 4 is negative 5, and then we've got all this mess out front. We have an even number of negative signs, so they'll cancel out in pairs, so we're left with something that's not going to be negative. And then 1 times 2 times 3 is 6, times 4 is 24. So we can see that there's a little bit of pattern going on here. When we take derivatives of x's raised to powers, we'll just continue dropping those powers out front. So we'll get something that looks like a factorial out front. And again, our x just being raised to fewer and fewer powers. Let's do one more example, and for this one, there's a little bit of a trick involved. So here, I want to take the second derivative of the square root of the square root of x squared plus 3 to the third power. And what I want to emphasize here is that there's a little bit of a shortcut, because what we could do is we could use the chain rule twice here. Oops. We could say, oh, I have my outside function and my inside function, and then my inside function is actually another outside function and an inside function. So when we look at this, we've got, say, 3 nested functions. I've got the big square root on the outside, I've got the function on the middle, that's take whatever and raise it to the third power, and then we have the function way on the inside. So we're plugging that into there, and then we're plugging all of that into there. So we've got 3 nested functions. However, we don't necessarily have to think about this as 3 nested functions. So this is a valid way to do this, but I'm not going to do it that way, because if I take the square root of something, that is actually just the same thing as taking it to the 1/2 power. So this is the same thing as x squared plus 3 to the third power, and all of this to the 1/2 power, and an exponent raised to an exponent. We just multiply the exponents. So this is going to be the same as the 3/2 power. And this is going to be a lot simpler to take the derivative of. So let's do that here. So if I'm going to take the derivative, so the first derivative of this guy, Again, we have the chain rule popping out because we have a function inside of another one. So the outside function is going to be raise something to the 3/2 power. So I will pull down that power, subtract 1 from the power, so 1 less than 3/2 is going to be 1/2. And then I have to take it times the derivative of the inside. And the derivative of x squared plus 3x, the derivative of x squared is going to be 2x, and the derivative of 3 is going to be 0. So I'm not even going to write down the plus 0 there. If I simplify this, I have a half there times the 2, so those will cancel, and I'm left with 3 times x times x squared plus 3 to the 1/2. Cool. Let's take another derivative then. This will be the derivative of 3x times x squared plus 3 to the 1/2. And we're taking the derivative of this whole thing, and we are multiplying these guys. So we have a product rule. So the derivative of this guy is going to be 3x times the derivative of x squared plus 3 to the 1/2 power, plus the second function times the derivative of 3x. And let's take this one step at a time. So we've got 3x times the derivative of this guy, and the derivative, again here, we see that we have a function raised to the 1/2 power, so we'll have to use the chain rule. We pull down that power, we raise what we had to the 1 fewer power, so it's going to be to the negative 1/2. And then we're going to take this times the derivative of the inside. Well, the derivative of x squared plus 3, we already saw that. That's just going to be 2x. Again, the derivative of x squared is a 2x, the derivative of 3 is a 0, so I just won't include that 0 there. So we have 3x times the derivative of this mess, plus we have x squared plus 3 to the 1/2 times the derivative of 3x. Well, the derivative of 3x is just going to be 3. And again, we can start to simplify this. So we've got a 1/2 and a 2. Those factors will cancel out. So we'll have 3. I've got my x squared. And then we've got x squared plus 3 raised to the negative 1/2. Plus 3 times this guy. And maybe this would be a good point to say that we can actually simplify this a little bit. I can rewrite this on the bottom of a fraction. So this is going to be 3x squared over the negative 1/2. So the negative puts it on the bottom. The 1/2 says that this is just the square root of x squared plus 3. And then I'll write this as 3 times the square root of x squared plus 3. But in order to consolidate these fractions, I want them over the same common denominator. So I can write this as a fraction with a 1 on the bottom. So I'll multiply the top and bottom by x squared plus 3. And now these have the same common denominator. They have they're both over the square root of x squared plus 3. And on top, I'll have my 3x squared plus 3 times this guy. So this is 3 times the square root of x squared plus 3 times the square root of x squared plus 3. Well, if we multiply square roots, we just get that function back. So this actually simplifies down quite a bit. So I have 3x squared plus 3x squared is 6x squared. And then the 3 times the 6, well, that'll be 9. But rather, let me pull out a 3 out front. So it's going to be 3 times 2x squared plus 3, all over the square root of x squared plus 3. And I believe that this would be as simple as possible to write this down. I will stop here, and in the next video I will talk about one of the uses of looking at the second derivative.